Welcome to Vijaya Mary Public School. Own digital classrooms.
You know, we're surrounded by this stuff every single day. But how often do we actually stop and think about it? I'm talking about the fundamental states of matter. So today, let's just dive in and break down the science behind solids, liquids, and gases.
All right, let's kick things off with a little question. What do you think an ice cube, a puddle of water, and a cloud of steam all have in common? I mean, it might seem kind of obvious, but trust me, the answer is the key to, well, pretty much everything we're talking about today.
And yep, if you were thinking they're all just water, you absolutely nailed it. It's amazing, right? That one single substance, good old H2O, is going to be our perfect guide for this whole journey through the three states of matter: solid, liquid, and gas. Okay, so first up, the unchanging solid. This is matter when it's at its most structured, its most rigid. Think of it like all its tiny particles are locked together in a super tight hug. So, what is it that makes a solid a solid? It really comes down to two big things. It has a fixed shape and a fixed volume. An ice cube is always an ice cube, right? And that's because if you could zoom way in, you'd see its particles are packed together in this super tight, orderly grid. Now, they're not completely still. They're actually vibrating with a little bit of energy. But the key is they can't break free. And that right there, that's the whole secret to why solids keep their shape. Those particles are just locked into place. They have basically zero freedom to roam around, which is why, a block of wood or a stone feels, well, so solid. Okay, but what happens if we give those particles just a little more freedom? Well, that's when we enter the world of the flowing liquid. This is where things start to get a whole lot more adaptable. Yeah, this is where it gets interesting. A liquid doesn't have a shape of its own, right? It just takes the shape of whatever you pour it into. But, and this is important, its volume is still fixed. A liter of water is always a liter of water, doesn't matter if it's in a tall glass or a wide bowl. And why is that? It's because its particles are still pretty close, but now they've got just enough wiggle room to slide and tumble past each other. And that freedom to move, that's exactly why liquids can flow. I like to think of it like this. In a solid, all the particles are holding hands, stuck in one spot. But in a liquid, they're still in the same group, but they've let go of each other's hands, and now they can kind of weave through the crowd. All right, now let's crank the energy up all the way. We are now entering the world of the free-roaming gas, and this is where the particles just totally break free. When it comes to gases, it's like we just throw the rulebook out the window. A gas has no fixed shape and no fixed volume. Its particles are just so far apart and they're moving so incredibly fast. They're like these little tiny rockets just zipping all over the place. And that's exactly why the air you're breathing right now is filling every single nook and cranny of the room you're in. So why do they spread out like that? Well, it boils down to two simple things: a ton of energy and huge distances between each particle. There's almost nothing holding them together, so they just expand and keep expanding to fill any container they're put in.
Okay, so we've looked at each state one by one. Now let's kind of zoom out and put them all side by side so we can really see how they stack up.
So let's go back to our trusty guide: water. You start with solid ice, you add a little bit of heat, and boom, it melts into liquid water. You add even more energy, and it turns into steam, a gas. It's the exact same molecule, just on this incredible journey through the different states. Okay, let's bring this all home. Time to put everything together. This table pretty much tells the whole story, doesn't it? Just look at the pattern here as we go from solid to liquid to gas. For shape, we go from fixed to takes the container's shape to no fixed shape at all. For volume, we go from fixed to fixed again, and then suddenly not fixed. And the why behind all of this? It's right there in those bottom two rows. It's all about movement and distance. As you go from left to right on this chart, the particles just move faster and get farther apart. Honestly, that's it. That's the whole secret. So if there's one thing you take away from all this, let it be this: the state of matter is really just about how its particles are packed and how they move. That's the crucial point. If you can answer those two things, you can understand pretty much any substance. So we've covered the big three, right? Solid, liquid, and gas. But that leaves us with a really fascinating question. Is that it? Are those the only states of matter in the entire universe? Or could there be other, way more exotic states out there just waiting to be discovered? Well, that's a story for another time.